Hi, today we're going to talk about triangle similarity. Objective is I will learn to prove certain triangles are similar by using AA, SSS, and SAS. We'll talk about what those mean in just a second. We kind of want to review what it means to be similar. When polygons are similar, two criteria must be met. This is review corresponding angles are congruent, and then corresponding sides are going to be proportional. Okay. However, if you don't know the measure of all the sides and all the angles, is there another way to tell? And well, for triangles, the answer is yes. There are several theorems that allow us to show that triangles are similar. The first one is going to be angle-angle similarity. Okay, and it says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. All right, so what that means is if I call this a triangle ABC, and we call this triangle DEF, all I need to know is two pairs of corresponding angles. So if I say A is congruent to D, and let's go with C is congruent to F, then that means triangle ABC is similar to triangle DEF. Right? So let's look at a couple of examples. Can these triangles be proven to be similar by angle-angle? If so, write the similarity statement. Well, I have two angles here that are congruent and two angles here that are congruent. So let's go ahead and write this. Angle AEC is congruent to angle DEB. And then angle C is congruent to angle B. So the answer would be yes. And then we can just write this as angle AEC would be congruent to angle DEB. All right. Now let's look at this next example. I have notice I have these two little arrows right here, which mean that side JK and side FG, those are parallel. So that creates this alternate interior angles right here that are congruent. And then I have these vertical angles that are congruent. So then the answer would be yes, because I have two pairs of angles that are congruent. So let's call this angle triangle JHK. And then I would have to go FHG on the second triangle. All right, for the next example, we're going to use angle-angle to find the missing measurements. So now we're going to go ahead and we're going to use this angle-angle. So given AB is parallel to CD, so kind of like the picture we just looked at, the sides are parallel, which means I have some alternate interior angles that are going to be congruent here and here. And then I know these vertical angles are always congruent. So if AB has a distance of 4, AE has a distance of 3x plus 1, CD is 8, and ED is x plus 12. All right, corresponding sides is going to be 4 to 8, so that's going to be my ratio. I'm going to solve this using proportions. 4 is to 8 as 3x plus 1 is to x plus 12. And I'm going to use cross products. So I got 4 times x plus 12 is equal to 8 times 3x plus 1. I got to distribute, so it gives me 4x plus 48 is equal to 24x plus 8. All right, I'm going to move the 4x, I'm going to subtract, it's going to give me 20x on this side. And then I'm going to subtract the 8 to move over here to the 48. 48 minus 8 is going to give me 40. So if I divide by 20, it's going to give me x is equal to 2. Right? But I'm not done yet because it says find AE and DE, so that means I'm going to have to substitute into these two expressions. So AE is going to be 3 times 2 plus 1, which is 7, and DE is going to equal 2 plus 12, which is 14. Right. So AE is 7, DE is 14. All right, next similarity is going to be side angle side. All right, if two triangles, excuse me, if a pair of corresponding angles is congruent and the sides including the angle are proportional, then the triangles are similar. All right? So if I had this side corresponding to this side, guess I can put some X's on here instead of, because they're not congruent, but they are similar. They would correspond. So if this side corresponds to this side, and let's say that this side corresponds to this side, and I know the angle in between them, the included angle of both of these triangles, if they're equal, then the true triangles are similar. So again, kind of like last time, label these A, B, C, and D, E, F. I would say triangle ABC is similar to triangle DEF. Again, the sides have to be proportional. The included angle has to be equal. All right, so let's look at what something like this might look like. Can the two triangles be proven congruent or similar? I noticed the angles right off the top. Those are equal, so that's good. We have the A kind of checked off. Now we got to match up the sides. This is shorter than the 6, so this 4 was going to have to match with this 6. So if I do 4 over 6, and then I do 6 to 9, okay, if I cross products, this is going to give me 36, and 4 times 9 is 36, 6 times 6 is 36. So yes, the ratios are equal, so the answer is yes, and then we can go LMN would be congruent to QPR. All right, now it's time for the third way that we can show the triangles are similar, and this one is called side, side, side. All right, and if all three pairs of corresponding sides of two triangles are proportional, then the two triangles are similar. Okay, so if I go A, B, C, and D, E, F, all right, so if the ratio of AB over DE is equal to the ratio of BC over EF, and the third one would be AC over DF. If the ratio of these three are the same, then the triangle, excuse me, is similar. So let's look at this next example here. All right, yes or no. So I'm going to compare these. It looks like 3 is the shortest side on this one. The short side of this is 9, so that's going to be 3 over 9, which would be 1/3. Then we have 4 to 12, which is also 1/3, and 5 over 15, that reduces to 1/3. All three of these have the same ratio, so then the answer is yes. And then we would go STU. Triangle STU is similar to XWV. All right, next set of questions here. Are the two triangles similar? If so, state how and what similarity. All right, so I have this triangle XWV that's inside this larger triangle XZW. All right, so this angle is 80 and this angle is 80. The only other thing is that they share this angle X right here. If I kind of make this triangle over here, WXV, right, this angle is the angle, same angle that's inside this larger triangle. Right, so the answer would be yes. How would be angle, angle. Since this angle is the same to this one, and both of these are 80, so this would be 80 as well. Right, and then so we would say XZY would be similar to XWV. All right. Now for this middle triangle, or this middle problem, I have this triangle LKM compared to LJN. So I would use, of course, they have that same angle in common. And then I need to look at 6 over 9, because really this distance from L to J is 6 plus 3, which is 9. And then on the other side, I would need to compare that to 10 over 10 plus 5, which would be 15. So this would reduce to 2/3. And if I take this one and I reduce, that's going to be 2/3 as well. So if I factor out 5 from both of these, so I got 2/3 and 2/3 as my ratio. This would be yes. How would be side angle side? Because I'm looking at this proportion, this angle, included angle, and then this side over here, or these two sides. And then we would have triangle JLN would be congruent to triangle KLM, or not congruent, similar. All right, now this last one, I'm going to have to kind of rotate this one around. So if I draw it here, flip it, H would go on top, F, I'll put that there, and E would go over here. So this is going to be 6, 10, and this whole thing is actually going to be 12. Because I'd have to add the 6 plus 6. Okay, so then 3 is to 6, well that's 1/2. 5 is to 10, that's 1/2. And then 6 is to 12, that's also 1/2. So I got 1/2, 1/2, 1/2. So this would be yes, side, 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 since all three ratios were equal. And then we would say DEG, and then we would have to go with HFE as my similarity statement. All right, for this next example, we need to solve for x and y. I'm going to go ahead, and since these are parallel, that's going to give me those alternate interior corresponding angles actually that would be congruent. And then they would share this angle C right here. So I know these two triangles are similar. To solve for x, what I'm going to actually do is I'm going to set this up as a proportion where I keep the x's to 3 as 3 is to 4. All right, 3 is to 4. So then we're going to go cross products. It's going to give me 4x is equal to 9, which means x is going to be equal to 9 over 4. And you can leave that as a fraction, or if you want, you can make that a decimal, which would be 2.25. All right, now we're going to do kind of the same setup with the y here, except for I need to, since I'm looking at this whole length right here and this whole length here, when I go in to set up my ratio, if I'm doing y over 8, then I would need to do 4 over 7, because I'm looking at this side right here, CD, going to CE. So that's where the 7 is coming from. I'm adding the 4 and the 3. So that gives me 7y is equal to 32. If I divide by 7, y is going to be 32 over 7. All right. And then I'm going to leave these last two examples up to you. I want you to try these two on your own. And when you come into class, you can ask me and we can go over them to make sure you got them correctly.